The next method for unsteady flow we call the modify this procedure or Copper and Jacob method. Okay, to simplify the wave function, we use just only two terms. This is a full series of the wave function. So we just bring just only two terms of the wave function and substitute in the equation of drawdown. Okay, and we can rearrange this equation, convert from ln to log. So we got this equation to estimate drawdown. We don't need to open the wave function anymore. Okay, we can estimate. The next, if you want to apply this equation for the pumping test, we start from, if you have two wave function from different time and radius, we got this equation, and the wave function from different time and the two time and two radius. Okay, and let's do the same for the drawdown. If we have u1 and u2 different time and location. Okay, and if we assume that we do observation at the same point, the r1 is equal to r2, so it's cancel. So we got the difference of the drawdown in terms of this equation. Next step, we plot the graph between drawdown and time. Okay, and if we choose that time t1 and t2 in a one log cycle. For example, if we choose the t1 is 30, t2 is 33, 1, or can be 10, 1. Okay, so it means t1 and t2 is different for one log cycle. So if we take a log on this term, going to be 1. Okay, because of different of the time is one log cycle. We can look at this curve. For example, this one we pick up we find a slope. This is slope between t and drawdown, and we find the slope delta z. From a log cycle between 1 and 10. Okay, so we can estimate delta z from one log cycle of time. Okay, and this we can estimate the t based on this equation. And next for at the t naught, for t naught, at t naught is mean at the drawdown is 0. When the drawdown is 0, it means we can draw the curve to cut the axis. For example, this one, we draw the curve to cut axis at this point, so we can estimate what is the t naught. At this point, it means the drawdown is 0. Okay, drawdown is 0. So once drawdown is 0, it means wave function is 0. If your function is 0, u is equal to 0.562, and we can rearrange this equation to get the sortivity is equal to this. We can estimate sortivity based on this equation t and capital T and t naught. Okay. In this case, S is sortivity or storage coefficient.